In this presentation, we are going to study Quine-McCluskey Minimization Technique, also called as Tabular Method. For many applications, the number of inputs is too large, so the simplification using Kmaps becomes too difficult. This happens when the number of variables is greater than 6. You already know two methods for minimization. The first one is Boolean algebra, second one is Kmap, and third one we are going to study in this presentation called as Tabular Method. Kmaps are good. You can use Kmaps for 3-4 variable minimization, 5 variables also, and when you have 2 or 3 variables you can use Boolean algebra. But when you have more variables, it will be very difficult to use Kmap as well as Boolean algebra. So we have this method when the number of variables are greater. This technique is based on automatic or computer driven simplification routine. We can use this technique for designing very complex digital systems. We need to brush up two important terms, prime implicant and essential prime implicant, before moving to our tabular method. So first term is prime implicant and second term is essential prime implicant. We have already studied about implicants in Kmap lecture, so I'm going to cover this quickly. Implicant is nothing but the group of ones, and prime implicant is the largest possible group of ones. Essential prime implicant is the prime implicant having at least one minterm that cannot be combined in any other way. So this is all that you should know about prime implicant and essential prime implicant before moving to the tabular method. We will take one example to understand all the steps involved in the tabular method. Example, and let's say the function is y with variables a, b, c and d. A is MSB, the most significant bit, d is LSB, the least significant bit, and the minterms are 0, 1, 3, 7, 8, 9, 11 and 15. So these are the minterms, and we have the function y with 4 variables. Now I am taking 4 variables to explain you the tabular method. However, it was good to use Kmap to solve this problem, but I don't want complexity. This is the first problem in tabular method, and I want to avoid the complexity. I want to keep this lecture as simple as possible. Once you understand all the steps involved, you can easily solve the problem with 5 variables or 6 variables. So we will take this example, and at the end of this presentation, once we have the minimized function by using the tabular method, we are going to verify by solving it with Kmap. So let's move to the step number 1. Before that, I will write down the binary equivalent for this minterms. I hope you already know these things. No need to write down in your exam, but for reference, I'm going to write down the binary equivalent of 0 is 0, 0, 0, 0. We are having 4 variables a, b, c and d. For 1, we have 0, 0, 0, 1. For 3, we have 0, 0, 1, 1. For 7, 0, 1, 1, 1. 8 is 1, 0, 0, 0. 9 is 1, 0, 0, 1. 11 is 1, 0, 1, 1. And 15 is of course 1, 1, 1, 1. So these are the binary equivalents for the minterm given. And in step number 1, what we have to do is to make a table. In step number 1, we have to make a table, and in that table we will arrange all the minterms according to the number of ones contained. So what actually we are going to do is to make the groups, and in each group we will keep the minterms with same number of ones, right? For first group, we are going to have the minterm with no 1. It means 0 is going to be in the first group. In second group, we are going to have the minterms with single 1. So you can see 1 is having single 1 and 8 is having single 1. So 1 and 8 are going to be in group number 2. In the same way, we have to make the group for the minterms having 2 ones, 3 ones and so on. So this is what we are going to do in step number 1. We will make the table with 3 columns. So let's do it quickly. this is first column, this is second column, and this one will be the third column. Okay, and in first column we will have the group number. In second column we will have the min term, and in third column we are going to have the binary representation. And as you can see, we have 4 bits, A, B, C and D. We will fill this table depending upon the number of ones, so let's do it. In group number 0 we are going to have the min terms having 0 ones, and there is only one min term M0 with 0 ones. So in group number 0 we will have M0, and the binary representation would be 0 0 0 0. In group number 1 we will have the min terms with single 1, and as I have already told you, 1 and 8 are the min terms with single 1. So we will have M1, M8. M1 is 0 0 0 1, M8 is 1 0 0 0. In group number 2 we will have the min terms with 2 ones. So let's see what are the min terms with 2 ones. 3 is having 2 ones, 7 is having 3 ones, 9 is having 2 ones, and 11 and 15 are having 3 and 4 ones respectively. So we have M3 and M9. M3 is 0 0 1 1, M9 is 1 0 0 1. In group number 3 we will have the min terms with 3 ones, and you can see 7 is having 3 ones and 11 is having 3 ones. So 7 and 11 will be there in group number 3. M7, M11, 7 is 0 1 1 1, 11 is 1 0 1 or 1. And the group number 4 will have the min term with 4 ones, and we will have only M15 in group number 4. So this is what we have to do in step number 1. We have to form these groups depending upon the number of ones in the binary representation of the min terms. In step number 2 we are going to use this table and we will fill another table. So in step number 2 we will have to make another table, and that table will be same, and we will fill that table depending upon this table that we will see shortly. So let's make the table quickly. Okay, first column is for group, third column is again for binary representation A, B, C and D. Now the second column will have the matched pairs. Now what is this matched pair? This is a new term and very important in tabular method. The matched pair we obtain when we compare the nth group with n plus 1th group. If 0 is the group, then 0 plus 1 is 1, and we have to compare the group number 0 with group number 1 and we will obtain the matched pairs. So a matched pair is nothing but it is a pair of min terms which only differ by one variable. Very simple. If we compare the min terms of the group number 0 with the min terms of group number 1, for instance, let's say I'm comparing M0 with M1, then it is a matched pair only if there is a difference of one variable. So let's see, A, B, C are 0 in case of M0, and also they are 0 in case of M1, but D is 0 for M0 and it is 1 for M1. So we can say only one variable is changing. Hence M0 M1 is a matched pair, and we have to identify the matched pair from this table, and we have to fill the matched pair in step number 2. So this is what we have to do in step number 2 in this table number 2. So group number 0 will have all the matched pairs when we compare the group number 0 with group number 1. In the same way, the group number 1 will have all the matched pairs when we compare group number 1 with group number 2, and so on. You will get a clear view once we will start filling this table. I have already compared M0, M1, and this is our matched pair. So M0, M1 is matched pair, and A is 0, B is 0, C is 0. Now what about D? For D, we are not going to write 0 or 1, but we will write underscore. This shows that D is eliminated. Now we will compare M0 with M8, because we have to compare each and every minterm of nth group with the minterm of n plus 1th group. And when we compare M0 with M8, we can see B, C, D are 0, but A is 0 and 1. So this is again the matched pair. So M0, M8 is our matched pair, and we have underscore 0, 0, 0. Right. One very important thing that you have to keep in your mind is when you have the minterms in your matched pair, you have to put a tick mark in front of them. For example, M0 is in our matched pair, so I will put a tick mark in front of M0. M1 is also there in matched pair, so I will put a tick mark in front of M1. In the same way, in front of M8. I will explain why we are putting this tick mark in front of minterms shortly. Let's move to group number 1. I will compare M1 with M3, and we can see that only one variable is changing. M1 is 0, 0, 0, 1. M3 is 0, 0, 1, 1. Only C variable is changing. So M1, M3 is matched pair, and we have 0, 0, underscore 1. I will compare M1 with M9, and let's see what we have. 0, 0, 0, 1, 1, 0, 0, 1. Again we have only one variable changing, so M1, M9 is also our matched pair, and we have underscore 0, 0, or 1. In the same way, we are going to compare M8 with M3, M8 with M9. I'm not going to do this. Fill this table by yourself, and then we will move to step number 3. I hope you have the same table in your notebook, and don't forget to put the tick mark in front of the minterms that are involved in the matched pairs. So this is step number 2, and now we can move to step number 3. In step number 3, we are going to use this table, and we have to follow the same steps. We have to compare M0 M1 with M1 M3. In the same way, we have to compare M0 M8 with M1 M3, and so on, and we have to again check for the matched pairs. So in step number 3, we are going to do the same thing that we have done in step number 2. We will make the table, and we will find out the matched pairs. So let's make the table quickly. Okay. Group, matched pairs, binary representation A, B, C, and D. We will compare M0 M1 with M1 M3. M0 M1 is 0, 0, 0, underscore. M1 M3 is 0, 0, underscore 1. So you can see that we have two variables changing, underscore 1, 0, underscore. So M0 M1, M1 M3 is not a matched pair. Now this is not a matched pair. We will compare M0 M1 with M1 M9. So let's do it quickly. 0 0 0 underscore, and m1 m9 is underscore 0 0 1. Again you can see we have two variables changing, so it is not a matched pair. In your rough space, do it the way I'm doing to avoid the mistakes. This is the method in which most of the people commit mistake. So this is again not the matched pair. We will compare m0 m1 with m8 m9. So 0 0 0 underscore, m8 m9 is 1 0 0 underscore, and you can see we have only one variable changing, that is a. Rest of the variables are same. So in group 0 we have m0 m1 m8 m9 as our matched pair, and the representation is going to be underscore, this 0 1 will be written as underscore 0 0 underscore. In the same way you have to complete this table. I hope your table is same as this one, and don't forget to put tick mark. All the matched pairs are involved, so I will put tick mark in front of all these matched pairs. In step number 4 we have to repeat the same procedure. We will compare group number 0 with group number 1 and group number 1 with group number 2, and we'll write down the matched pairs. But you will find that there is no matched pair after step number 3, and thus we don't need to put a tick mark in front of this matched pairs, and we will write the values for them. B complement, C complement, A is eliminated, D is eliminated, so B complement, C complement. In this we have B complement D, and for this we have C D. This is our prime implicant. All these three are prime implicant, and we have to also check for the step number 2 if there is any matched pair which is untick, but there is tick in front of all the matched pairs, so they are not prime implicant. In the same way we have to check for table number 1, and all the min terms have tick in front of them, so they are also not the prime implicant. So we have prime implicants B complement, C complement, B complement D, C D. Now we have to make another table, and we will call this table prime implicant table. So we are going to make the next table, and this is our prime implicant table. Okay, we need more space for this prime implicant table. In the first column we are going to have the prime implicants. They are B complement, C complement, B complement D, C D. We are making this table to find out the essential prime implicant. These three are the prime implicants but not essential, and the minimized function will only have the essential prime implicants. So this table will help us to get the essential prime implicants. First column will have the prime implicants, second column will have the min terms involved, will have the min terms involved. In B complement, C complement, you can see we have M0, M1, M8 and M9. M0, M1, M8, M9. So we are going to write it down 0, 1, 8 and 9. In the same way for B complement D, we have 1, 3, 9, 11. 1, 3, 9, 11. For CD we have 3, 7, 11, 15. 3, 7, 11, 15. And also we have to write down the given min terms. If you see the problem, and you will find out the given min terms 0, 1, 3, 7, 8, 9, 11, 15. We have to write down this in the last column. 0, 1, 3, 7, 8, 9, 11 and 15. We will put a cross in each row under the min terms contained in particular prime implicant. In this prime implicant we have 0, 1, 8, 9, so we will put a cross under 0, 1, 8 and 9. In the same way, we will put a cross under 1, 3, 9 and 11. 3, 7, we have 11 and 15. I will make the columns so that I can separate them more clearly. Okay, now we have to circle the cross. We will circle the cross which is alone in the column, like this one. In this column we have 2 cross, in this column also we have 2 cross, but in this column we have only 1 cross, and this is also the column having the single cross, and this one is the column having the single cross. Now we will consider the prime implicants corresponding to this circle. For this 2, we have b complement c complement, so function y is equal to b complement c complement, or corresponding to this 2 we have cd. So this is our answer, and you can see we have eliminated b complement d because this is not essential prime implicant, and we can prove it with the help of Kmap. If I draw a 4 variable Kmap, we are going to have 16 cells. Okay, this is our 4 variable Kmap. The variables are A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. We are going to fulfill this Kmap quickly. 1, 1, 0, 1, 0, 0, 0, 1. We have 8 and 9, so 8, 9, 10 is 0, 11 is there, 12 is 0, 13 is 0, 14 is 0, and 15 is 1. So this is what we have, and this is our first prime implicant, and this one is our second prime implicant. 1, 2, and they are essential prime implicant because this one cannot be combined in any other way, and these 2 ones cannot be combined in any other 2 ways. So these are our essential prime implicant, and let's write down the minimized value for the first group. You can see we have CD, or for the second group we have B complement, and you can see we have C complement. So from Kmap also we got the same answer. In order to get B complement D, we have to make another group of ones, the pink one, and this will give us B complement D, and this is absolutely a redundant thing to do because this 4 ones are already combined in first and second group of ones, so no need to combine this 2 plus 2 4 ones again. So B complement D is prime implicant but not essential prime implicant. So this is all for this presentation. In the next presentation we will see tabular method with don't cares. So see you in the next one.